Welcome. I hope everyone had a good weekend. This is a live stream where we take a look at different source code repositories and poke around and see what we can learn by just exploring the source code, like some sort of source code archaeology. And today we're looking at the Python rules for Bazel, also known as Bazel build rules Python. This is part of my schedule has a bunch of theme days for each day of the week. We emphasize a different theme in terms of what we're looking at. And on Mondays, we've been looking at source code from the Google ecosystem that's open source. We looked at Bazel in, I think, 3 other videos. And that was intended to be a single video that kind of got interrupted. So I'll link those videos in the description. And in those videos, we were really looking at, I guess what you would call Bazel core, or just the main Bazel framework. And then for each programming language, Bazel has some language-specific rules. And I thought I would look at rules Python for a couple of reasons. One is Python's a little bit of a difficult case in terms of making reproducible builds. Python has dynamic typing and it's got duck typing. And for a while, before the typing rules in Python 3, there wasn't a lot of type information in Python source code. And so at least back in the day, a few years ago, when I was at Google, Python was kind of the hard case for Bazel. You would sometimes build things, and then in the middle of the build would fail and let you know that like some dependency had an issue, but you couldn't really catch that dependency earlier on in the build. And it was often difficult to figure out what the root cause was, and even how to fix it. So that's why I wanted to look at Python. I believe, or at least it used to be the case, that for Python, when Bazel is doing things like collecting all of your dependencies and downloading them and putting them into the Bazel sandbox, it basically called out the pip. And so you would have somewhere in your repository, you would have like a requirements.txt file. And I think what happened was Bazel would read that and that would maybe be like a source of truth for the dependencies you could list as you were modeling out your dependencies in the build files. That, calling out to pip has its benefits. The big one of which is that pip already does a bunch of work that the Bazel team doesn't have to duplicate. People expect pip to work and those sorts of things. But it also has some complexity in the sense that the requirements of pip aren't necessarily the same as the requirements of Bazel. And so there's what you might call an impedance mismatch, where you kind of have to figure out what's the right way to think about using an external or rather a third-party dependency management system as part of Bazel in a way that feels seamless with Bazel and gives you all of the benefits of having reproducible builds in the Bazel sense. So that's why I picked Python first. And I guess we'll just poke around. I don't think I've really looked at this this repository yet. So we'll see what happens. I am actually going to pause for 1 second. Okay, I'm back. Okay, so I'm on the Bazel build /rules Python GitHub, and let's see. Let's just double check that this is still the right place to be. Yeah, it's the home of the core Python rules. Commits are pretty recent, 3 weeks ago, 2 weeks ago, that sort of thing. There's a README, which is this thing. It tells you how to get started. You load the rules like this. You have to register a Python toolchain. It says a hermetic Python toolchain. because it's not the system toolchain. It's somehow a version of Python that I think Bazel is going to download for you. And that way you always have the same exact Python binary interpreter, whatever you want to call it, that's building all of your stuff and running all of your stuff. All right. Okay, so let's look at the directories. We've got Gazelle, which is a Golang-based tool to auto-generate build files. I'm not sure that the Gazelle dependency was there when I first started using Python. So I'll take a look at that. And let's see what else we have. We have proposals, which we might as well look at. I'm guessing this is going to be kind of like design proposals. Python is almost certainly important. And we'll look at the tests and the tools. We'll look at tools first because I'm not sure whether tools is going to be important or not. Oh, that's Gazelle. Here's tools. All right, we've got integration tests and build devs Python. I'm not sure. And then publish. And then update coverage depths and wheel maker. Wheels, I think, are part of the Python like build pip ecosystem, I believe. So let's actually take a look at all of these and see what's up. So here's wheel maker. I just want to get a sense of what's going on here. So wheel maker is going to take a name, a version, a build tag, a Python tag, and you can get the, I guess this is getting the wheel name. Yeah. You can add a string, add file. Maybe this is for creating wheels. Add wheel file, add to record, resolve version stamp. Okay. Let's actually look up what a Python wheel is. Python WHL files. All right. It's a built package format for Python. Development status beta. I'm not sure that's up to date. Okay, this is the reference implementation of the Python wheel package standard as defined in PEP 427. The wheel binary package format. So it's a binary package format. It's a way of bundling Python as a binary. So here's some integration tests. We've got a test runner. And let's look at Bazel integration test. We've got some sort of, I guess, a pointer essentially to the Bazel binary. All right. Config imp. Okay, this looks like maybe it's in Starlark. Although it's it's a .bzl file. So this is in the Starlark kind of Bazel configuration library language, which is essentially a version of Python that is, I'm not sure if it's, I think it's perhaps not Turing complete or it may be Turing complete, but it eliminates certain things to reduce the complexity of your build environment. Like I think you can't have arbitrary loops. You might be able to have like limited looping, but it makes it more of a configuration language than straight Python, which is a bit unwieldy or maybe too powerful to use as a configuration language. So we've got def Bazel integration test. It's a wrapper macro to set sources and run a PyTest with config. Okay, so this is, I guess, a Bazel rule for defining an integration test. Okay, that's what this is. All right, cool. Okay, what do we have here? We have build depths Python, and here we just have build Bazel and tests. So I'm not sure. So I guess these are probably maybe the main tests for PyTest, PyLibrary, and PyBinary. You have a fake CC toolchain config and some Py executable base texts. Okay, so this seems like possibly interesting, but maybe not the heart of what we're looking at. Okay, and so in publish, we have some stuff. You can publish to PyPy with Twine, whatever Twine is. I guess let's take a quick look at Twine. It's utility for publishing Python packages to PyPy and other repositories. All right, so it's for publishing to PyPy. That's what's up. Okay, here's Gazelle, the Gazelle directory. Contains a plugin for Gazelle that generates build file content for Python code. So I guess you'll need to install Gazelle. And then you'll have to configure it. You have this Gazelle Python manifest thing. Gazelle Python extension needs a manifest file mapping from an import to the installed package that provides it. All right. Finally, you create a target that you'll invoke to run the Gazelle tool with the rules Python extension included. Yeah, so you run Gazelle, and Gazelle, like populates your working directory with build files and whatnot. Proposals. Okay, so these end at 2019. And what do we got? A design for the Python toolchain from 2019, customizing the Python stub template for 2018, and selecting between Python 2 and 3 from 2019. And Brand John, I think I recognize as I forget what I know about Brand John, but I guess he's the designer. So let's take a quick look at design for the Python toolchain. Error in user YAML. All right. This outlines the design, essentially a new Py runtime pair toolchain, thereby making runtimes discoverable via toolchain resolution. The goal is to make native Python rules use the toolchain framework to resolve the Python runtime. Okay, so this is this might have been added maybe like after the toolchain framework was finalized. Maybe they had a non-toolchain version of Python, and then this was added, I guess, to make it easier to specify that you want to use the Python via the toolchain framework, and basically pick exactly which version of Python you want. Okay, so at some point, I think I'd like to go do a thing where I look through design docs, because that's also very interesting in addition to the source code. But today we're going to focus on the source code. And then did I look at tests? Compile pip requirements, ignore root user error, load from macro, pip repository entry points, and run files. Okay, so we're going to ignore these for now, I think. And then here's rules Python/Python. We have config settings, constraints, pip install, private, run files, tests/toolchain. So we have more tests in here. Then we have a build file that's going to, I guess, build, this repo also needs to be built, and this is the thing that configures it, how it's built. We've got a bunch of Bazel files. In fact, I think these are all Bazel files. Yeah. Okay. So what Bazel files do we have? Current PyToolchain defs. We probably want defs. Extensions, maybe. Packaging. Definitely pip. Possibly proto. I guess let's do PyBinary. PyCC link params info. Maybe. We'll look at library and Python and repositories. And that should be fun enough. Okay, here is defs.bazel. So I think if I understand the convention correctly, these should be like the main definitions, or maybe just the entry point. So we're going to load tools Python source version.bazel. And we're going to get, and I think this find requirements function, which is presumably to find requirements.txt. And we're going to load a bunch of stuff, including internal some internal stuff like internal PyInfo, internal runtime info, and PyBinary, PyLibrary, PyRuntime, and some toolchain stuff. We're going to set PyInfo. So basically, we're going to export these things to their internal versions, PyInfo and PyRuntime info. And similarly here. Okay, so this is, I guess, maybe more of an entry point. And why just set PyInfo to internal PyInfo? Presumably so that the internal versions can evolve if necessary and you can as the internal ones are evolving, that's not necessarily visible to the external world. You can change how this definition looks in some sense. Okay, here's pip.bazel. Do we want to look at this first, or do we want to look at was there just one that was like python.bazel? Let's look at python.bazel. Okay, so this file has a comment that says it re-exports for some of the core Bazel Python rules. This file is deprecated. Please use the exports in defs.bazel instead. This is to follow the new naming convention of putting core rules for a language underneath rules lang/lang:defs.bazel. The exports in this file will be disallowed. Okay, so these are deprecated and anyway, there's not much here. Okay. So here's pip. All right, what are we going to do? We're going to load some stuff, including pip repository, repositories, requirements. And we've got pip install, which is going to take a requirements, which is by default set to none. The name, which I guess, I'm not sure what the name is for. Oh, it's going to tell us maybe? All right. Name is an optional string. It's a unique name for the created external repository. By default, it's pip, okay? And some keyword arguments. We'll print some stuff. Pip install is deprecated. Please switch to pip parse. Pip install will be removed in a future release. And then we're going to call pip start. Pip parse. Okay, and so pip parse has a different signature, but it still takes name. It takes a requirements lock, which is by default none, and it accepts the comment says accepts a locked compiled requirements file and installs the dependencies listed within. Okay, I'm not sure exactly what lock is, but you see kind of like a lock pattern in a bunch of dependency management systems. I think maybe it's a way of freezing requirements at a certain place, and often it's like auto populated. Like you set some list of possible requirements, and then there's like a lock file that actually resolves the requirements to specific version numbers that are compatible with all of your needs. So maybe that's what's going on, and then those are like stored in a file, and I think typically committed to source control, so that at every commit you have a specific set of dependencies. Right. These dependencies become available in a generated requirements.bazel file. You can instead check this requirements.bazel file into your repo. See the vendoring section below. This macro wraps the pip repository rule that invokes pip in your workspace file. Okay, and then there's some more stuff. Okay, so we're going to call pip install dependencies, which will, I guess, install the dependencies of pip. This is compatibility shim. We're going to get, I guess, requirements to use, and we're going to call pip repository. And that's really all we do. And then there's this multi-parse stuff, which I guess I'll ignore. And some stuff that looks like wheel. Let's see, wheel library alias implementation. It defines, okay, we get rules Python, default repo prefix, version map, build content. It's just equal to this string literal. And for alias in name package wheel data distinfo, we're going to build content append wheel library render alias target of alias name, default repo prefix, rules Python, version map, and wheel name. Cool. And we're passing in RCTX. And I'm not sure what that stands for. TX is maybe transaction. R is requirements or received. I don't know. And so essentially we're going to iterate over this list of aliases. And we're going to get the wheel name from everything we've passed in, and then ultimately call build content append. And then we're going to return rctx file build Bazel, and we're going to join all of the build content. So I'm not sure what rctx file is, but it kind of looks like this is building the build.bazel file out of the whatever's in the requirements.txt. And maybe rctx is requirements.txt, although that doesn't, there's no C in requirements, so who knows? Okay, we've got this other wheel library render alias target. Is that what we call here? Yeah, okay. So this is going to do this is like the inner loop. And let's see. We've got this select statement. I'm not sure exactly what that is, but that's going to give you an actual. So it's going to somehow resolve your alias to something actual, I suppose. And we're going to iterate over like essentially tuples, but really a list of Python version, comma, repo prefix in version map. And we'll append rules Python / Python / config settings is Python, blah, 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 actual format. Repo prefix rules Python. I'm not sure. I think this is some finding the right Python version, and this is some wheel stuff. Where did wheel name come from? Yeah, so it's being called with wheel name. So this is maybe writing the individual Bazel rules that are like appended and joined here, perhaps. And then repo, okay. All right. So wheel library alias is equal to a repository rule with all this stuff. We also have multi-pip parse, which is not intended for direct use. Okay. Python / py binary.bazel is just going to essentially export underscore py binary, which is essentially most likely, I guess, the internal version of py binary. PyCC link params info.bazel is just going to define this variable. It's the public entry point for PyCC link params info. Here's py library. It's just going to set py underscore library to underscore py underscore library. And here's repositories. This file contains macros to be called during workspace evaluation. For historic reasons, pip repositories is defined in Python pip.bazel. All right, so we're going to redefine HTTP archive as maybe, I guess, the internal version or the private version of HTTP archives, and we're just going to pass along our keyword arguments. Py repositories is a function that says runtime dependencies that users must install. This function should be loaded and called in the user's workspace. Okay. And it's going to download the Bazel skylib. So py repositories is something that you have to call. Let's see if in the README it tells you to call that. I'm guessing it does. So let's see. So this one calls load and then Python register toolchains and then pip parse. What was that function? Py repositories. Should be loaded and called in maybe something else calls py repositories. Okay, I don't see a reference to it in the README. All right, the remaining content of the file is only used to support toolchains. So this is toolchain stuff. We can get the interpreter directory name, is standalone interpreter, Python repository implementation. So let's look at the repository implementation. We have rctx again, attribute distutils in content, and we're going to fail if they're both defined. Only one of distutils content should be set. wonder if we can find out what's up with RCTX. Repository CTX. Okay, repository context. Cool. All right. So it's uh, some context object that has information about the repository. So it contains information about the platform, the Python version, etc. A URL, I guess, of the repository. And then we check what the release name ends with. And if it's ZST, we're going to download some stuff and unZSTD it. I don't know what a ZSTD is. What else do we got? If not, unZST. So if we don't have unZSTD, then we'll have an error. All right. So if we're down here, then we succeeded in having unZSTD. And we're going to call tar to extract some stuff. And it's going to use the compression program unZSTD. So it's some compression format that I guess is used to compress the Python interpreter. If it's not an unZSTD file, the release file is not a ZST file, then we're going to call download and extract at the URL. And I guess that's all we need to do. We're going to see if you have any patches. And if so, apply them. Write distutils config with a Python installed. Okay, so we'll write whatever distutils is. And then we'll make the Python installation read-only. I guess, is this modifying the file system? It seems to be. So like we're going to touch some directory, some test directory. Could not determine the current user is root. Please run as non-root. Yeah, so it's going to modify, I guess, the file system to make it read-only. We're going to exclude some globs, I guess, because we're going to do something glob-centered. We'll ignore the PyCache. And we'll include things like bin, extensions, include lib, libs, share. All right. And then this is some long string. This is all in blue. And it's in blue because it's a long string that we're going to call format on. And format is going to take some globs, including the exclude and include globs and the Python path and all of that stuff. So it should have some sort of like template, right? So let's see if we can find where something is substituted. So this file says generated by Python repositories.bazel and load some stuff. Sources are a glob of this stuff. More globs. Sources include Python headers. I'm guessing, so we have this double curly braces here. Maybe that's just part of the select statement. We have an extraneous M here. Maybe that's part of the header format. And we're going to export some stuff, used only download coverage. Oh. I'm not sure exactly what is getting, yeah, okay, coverage attribute is getting, I guess, substituted. Collect code coverage is true. Let's see if you can find Python version no dot. Here's Python path. All right, so this is the stuff that's getting substituted, but let's see if we can find no dot as well. Yeah, all right. So this is somehow these curly braces, this might be part of like the mustache thing. So we're going to do some template substitution essentially in this created file, which makes sense. Then we're going to delete some stuff, I guess, that we're done. And we're going to return a dictionary that has things like the coverage tool, the disutils, the names, the patches, and presumably whatever we just built, unless we're just writing it to the directory. So build content is what we built. So do we return that? Okay, we're going to write it to a file, I guess, and then return some stuff. Okay. All right. Then we've got repository rule. What was the thing we just looked at, actually? That was Python repository implementation. Cool. So here's Python repository. It's going to be repository rule, and it's going to take the repository implementation. I don't know enough about how Bazel rules work, but this thing I know is common, that when you define a rule, you give it like essentially a function pointer to the implementation and a bunch of other stuff like doc comments and stuff. Okay. Cool. Oh, but this looks like so Python register toolchains. It's going to be toolchain stuff. Register multi toolchains. Okay. All right. Let's see. Let's see what else we got here. All right. That was Python. I feel like I must be missing files with lots of stuff. So we have run files in private. Maybe let's look in private. We have PyWheel Bazel, re-export stamp toolchains repo, util, coverage. Let's look at coverage, I guess. So PyWheel info is a provider. This seems kind of just like metadata. We have distribution attributes, requirement attributes, and other attributes. And then we've got some functions: escape file name segment. That seems like a utility. Replace make variables input file to arg. PyWheel implementation. So we'll replace some variables. Then we're going to declare some files. File name segment with stuff, and then .wheel. The name file is going to be ctx label name .name. The input to the package is going to be we're going to call it dep set on ctx files deps. Okay, so where did we get ctx? Is it passed in? Yeah, okay. So whatever we get in, we're taking the context. We're going to create some output files that are wheel files. And the context has the dependencies already, it looks like. And so this file is how for all those dependencies, do some wheelie stuff. All right. Wrap the inputs into a file to reduce command line length. So we're going to declare a file, target wrapped inputs.txt. And then for each input file, inputs to package to list. What's inputs to package? Okay, inputs to package is the dependency set. Okay. We're going to append to content. I'm not sure what content is, but it seems to be maybe some sort of list. And we're going to call input file to arg on input file and add a new line. And then we're going to write to the file we just created, the package input file. And then other inputs we're going to append to the input file as well. Okay. And we'll have some args, which we get mainly from the context, but we also have version, Python tag, ABI. I'm not sure where that came from. Let's see if we can find ABI. The distribution attribute. So I guess it's replace make variables. So it ultimately does come from the context, it looks like, but we may have massaged it. Okay. All right, and we check if stamping is enabled. And if it is, then we do some stuff. I'm not sure what stamping is. We change the arg some more. We have metadata files, which is going to be something.metadata.text. Description file and version are not embedded into metadata.text yet. It will be done later by wheelmaker script. We'll record some metadata like author, etc., and check optional requirements. Then we're going to write the metadata file and add it to other inputs. All right, now we merge console scripts into entry points. So entry points is going to be a dictionary from the entry points attribute. We're going to copy so we can mutate it. All right, if context attribute console scripts, copy a console script group that may already exist so we can mutate it. All right, so okay, so we're making copies so that we can change things. If any entry points are provided, construct the file here and add it to the files to be packaged. So what do we do with the entry points? We're going to declare a file entry points.text. Okay, so we're writing a bunch of text files. All right, that essentially are like the processed version of whatever we got from the context. If context attribute description file, I guess we'll add that too. All right, then the last thing we do, it looks like, is call context actions run, set the inputs to the dep sets, dependency set, set the output file, set the arguments, the executable, and the progress message. And the progress message is building wheel of the context set label. And then we're going to return default info and wheel info. The default info will have the dependency set of the out file, and the run files will contain ctx.run files of files.out file. Okay. All right. And then we're also going to return wheel info, where the wheel is the out file and the name file is the name file. You have this utility function to concatenate dictionaries. You have a struct for wheellib, and then wheel is a rule. Huh. Okay. And this is some sort of patch. Okay, I don't feel like I totally understand what's going on, but I understand more than when I started. So let's see. So somehow we get a context, right? Into, was I looking at package or wheel? I forget. So somehow we're passing in a context to all of this stuff. So let's see. That file I just looked at, that big function I just looked at, wheel implementation. So maybe if I look for who calls wheel implementation, I can find out more about what the call chain looks like. Is there a search function here? I think it was what, underscore wheel impl. All right, GitHub doesn't want to find the code that contains wheel impl. That's okay. See what else we can do to find it. Maybe we could look at constraints just for fun. Did we look at run files? I don't remember. So run files has init and run files. Okay. Bazel run files library. This is a Bazel run files lookup library for Bazel built Python binaries and tests. Learn about run files at the run files guide and Fabian's BazelCon talk. Okay. Yeah, let's look at runfiles.py. If false. Okay. We can create directories. Create returns a new run files instance. This object is either a manifest based, meaning it looks up run file paths from a manifest file, or directory based, meaning it looks up run file paths under a given directory path. Okay, and we've got the underscore run files returns the runtime location of run files. And we're going to define our location, which is going to take a path, a source repo, and that's it. And it's going to return the runtime path of a run file. Run files are data dependencies of Bazel built binaries and tests. So this would be things like test data. We've got environmental vars, current repository, find Python run files root, and we've got the manifest based where we look up stuff. Okay, cool. Py package implementation. Hello. Klepko Tleta? Is that an L? How's it going? And we've got Py package implementation. All right, let's see what we got. So the inputs are going to be the dep set. I guess this is doing transitive dependencies. And we're just iterate over the dependency info and the data run files for everything in the deps attribute. And how's this different? The second one. Data run files versus default run files. Okay. So this is Py package implementation. Okay. To do, / is wrong on Windows, but the path separator is not available in Starlark. Good morning. Okay, so something doesn't work on Windows, but I guess they have some way of making it work. So packages, we're going to replace the dot with the / for everything in attribute packages. And if not packages, filtered inputs is equal to inputs. So if we have no packages, we don't need to filter anything, I guess. Otherwise, we're going to set filtered files to the empty list. And then we're going to flatten the dependency sets. Wait, no. Flattening to list gives poor performance. Okay, so we're not going to do that. Instead, oh no, that's a to-do. We are going to do it, but we know that it gives poor performance is what's going on. And then for every input file, we're going to get the wheel by calling path inside wheel. I guess we're going to peek inside the wheel and get the path. And then we're going to iterate over the packages. And if the wheel path starts with package, we're going to append it to the filtered files. Okay. So what is this doing? This is, we're filtering things where the wheel path starts with our packages. So I guess we're getting rid of, that's eliminating any wheels. Where's filtered files? Filtered files has been input file. Okay. So it's eliminating any input files that don't depend on this package, I think is what's going on. All right. And then there's this struct. All right. Constraints just has a build at Bazel. I don't know what that's about. And we're just defining some aliases. Like this one is a constraint setting to use for constraints related to the location of the system Python 2 interpreter on a platform. And similarly for Python 3. Cool. Let's see, have we missed anything? I think we looked at PyBinary. We can look at Proto. Right? Yeah, we looked at PyInfo, I think, before. What is it? This is PyImport. I'm not positive we looked at this. We've got default info and PyInfo. PyImport is a rule that's got some doc string, and its implementation is PyImportImpl. And we're going to maybe load that from where? Oh, here is PyImportImpl. It's going to just set the import paths to stuff from the context. and then return some stuff. Okay, so that's really simple. Here's the proto. It's just going to set PyProto library to the private implementation. Let's peek around in private again. I'm guessing private is really the place to be. So here's the proto. Oh, this is for defining proto libraries. Okay, so we're going to have this proto info provider stuff, a filter provider, which is just we're going to give it a provider, and it's going to look in the dep list, and it's got this set builder stuff. In Python, this is called like a list comprehension, I think, for all the attributes for dep if the provider is in the dep. Okay, so we give it a provider, and it's going to return all the deps that contain provider. Okay. We've got PyProto aspect implementation. It generates and compiles Python code for a proto library. The function runs protobuf compiler on the proto library target, generating a .py file for each .proto file. Okay, so you're going to give it a target, which is like a Bazel target, and a context, the rule context. It's going to return a PyProto info list, or actually, providers collecting transitive information about generated files. Okay, so we're going to set underscore proto library to context rule dot attribute. So the attribute, I guess, of the rule that it's being called on. And we'll check the proto file names. And get some toolchain stuff. The API deps, we're going to get as a list from proto-lang toolchain info.runtime. All right. And then set generated sources to the empty list and start generating some stuff, I assume. So proto info is going to be target at proto info. And if we have direct sources, we're going to declare generated files. So I guess this just declares them, or does it actually generate them? I'm going to assume it declares them and then this compiles them. Proto common compile. And we're going to pass in context actions as the actions, and some toolchain stuff, and the list of generated files, and the plugin output directory. And the generated sources is equal to the Python sources. And the dependencies we're going to get by filtering the provider with PyProto info. And that's going to give us only the dependencies that have proto dependencies. And then we're going to turn those proto dependencies into run files by having this transitive thing. This is, I guess, two list comprehensions, and we're appending them to each other with the plus sign. Is that right? Oh, thanks, O'Brien Henry. For some reason, I can't see all of your comment, but the part I can see, I really appreciate. Thanks. I now I can see your whole comment. That means a lot. Thanks. Okay. All right. Okay, then yeah, I'm not sure what this is. PyProto info. Yeah, okay. So we're gonna get some transitive stuff, run files from proto deps and transitive sources. And then PyProto aspect. I don't know what an aspect is. I think this is maybe something from like an aspect-oriented programming pattern, but I don't know really what it is in the context of Bazel. I guess we can look it up. All right. This explains the benefits of using aspects and provides simple and advanced examples. Aspects allow augmenting build dependency graphs with additional information and actions. Some typical scenarios when aspects can be useful: IDEs that integrate with Bazel can use them to collect information about the project, and code generation tools can leverage aspects to execute on their inputs in target agnostic manner. Okay, as an example, build files can specify a hierarchy of protobuf library definitions, and language-specific rules can use aspects to attach actions generated actions generating protobuf support code for a particular language. All right, I'm not sure exactly what it's saying. Here's an example of an aspect. Print aspect implementation. If it has attribute sources, we're going to iterate through the files that make up the sources and print their paths. And then the print aspect, we're just setting this aspect. Okay. All right. I'll read this later. I'm not entirely sure what it's trying to say, but let's read the definition again. They allow you to augment the build dependency graph. So we've got this graph, which we saw before, and it's the dependency graph. It's like the DAG that we're going to figure out what needs to be built when, and we can augment it. So we're attaching some additional data. And what sort of data are we attaching? I guess anything. We just have some like API or function or whatever that we implement. And here's some examples of stuff you can attach. You can use aspects to collect information about the project. All right, I guess. All right. And then you can also do something about protobufs in a agnostic manner. What I don't understand is why you can't do this in some other way. But okay, so here's an example. Consider the following build file. It's got some stuff and some depths, and this defines, these are essentially nodes, and the depths are like edges. So this is essentially it's a graph, like an adjacency list, I guess you can think of it. And so here's the dependency graph. And the Bazel analyzes this dependency graph by calling an implementation function of the corresponding rule, in this case, Java library for every target in the above example. So we're going to walk the graph and call Java library for every target. Rule implementation functions generate actions that build artifacts such as .jar files and pass information such as locations and names of those artifacts to the reverse dependencies of those targets in providers. Okay? Aspects are similar to rules in that they have an implementation function that generates actions and returns providers. However, their power comes from the way the dependency graph is built for them. Okay, so they're similar to rules. An aspect has an implementation and a list of all attributes it propagates along. Consider an aspect A that propagates along attributes named depths. This aspect can be applied to a target X, yielding an aspect application node A of X. During its application, aspect A is applied recursively to all targets that X refers to in its depths attribute. Thus, a single act of applying aspect A to a target X yields a shadow graph of the original dependency graph of targets shown in the following figure. Okay, so we've got this I don't know why I'm so zoomed in. I think it's because my VM has pretty low resolution. Okay, so we've got this top graph, and it's the same as this bottom graph. And then we've got what it's calling the shadow graph. And so like A of W, I guess, has an edge to W, A of Z has an edge to Z, A of Y has an edge to Y, A of X has an edge to X. Those are the red edges. And then the blue edges are, I guess, essentially shadows of the original dependency edges. So these edges here are depths, here, and here. And then these edges here are not, this is a depth, but somehow we don't have Q in the graph. That's okay. But everything that does not have Q as a node and as a depth appears as a blue arrow. The only edges that are shadowed are the edges along the attributes in the propagation set. Thus, the runtime depths edge is not shadowed in this example, okay? That's this edge here. An aspect implementation function is then evoked on all nodes in the shadow graph, similar to how rule implementations are invoked on the nodes of the original graph. Yeah, I still don't understand, but my guess is that this is, so like, why do they need this? Presumably they need this because it allows you to build tooling more easily. And so somehow we're going to get essentially a copy of the graph, and we can use that to build extra stuff. So this extra stuff might be, like it said, information about the information that you need for like IDE features or whatever, or it might be like you need some subset of the protobuf dependencies, I guess, and you're just going to do all the protobufs here as an aspect. I don't know, But I'll look at these docs in detail later. Um, and next time I look at something Bazel related, maybe I'll have a better sense of what they're up to. At any rate, where were we? Okay, so we've got this proto library rule, and it's going to merge results of PyProto aspect into depths. Okay, and then PyProto rule is going to generate Python libraries from proto files. All right. Packaging. I don't know if we looked at packaging. We've got PyWheel info, PyPackage, PyWheel dist implementation. This is based on github.com/aspect build/Bazel lib copy to directory. Avoiding a Bazel build to aspect build dependency. Sad face. Okay. So PyWheel dist implementation is going to declare a directory. It's going to get the name file, which we saw like I guess a few minutes ago. We wrote a name file that contained a bunch of names. It was one of the many files that we wrote that we were just like recording stuff to the file system. And then we're gonna I guess shell out to make dir and copy. Right, and then we're gonna run shell, running these commands, and the mnemonic is copy to directory, copying files to directory. So this is maybe this is copying files from the so like I guess like pip is going to download a bunch of stuff. And that stuff is going to be in like pip defined directories. I'm wondering if what this is doing is copying them to Bazel defined directories. So let's see. The directory that we are going to do stuff to is from the ctx attributes.out. So that should be a Bazel directory. The name file is from whatever this thing we wrote in before. And we're going to make dir the out directory. And then we're going to copy from where? So ctx files wheel.path. Yeah, okay. So we're going to copy from the wheel path to the directory path. And the output of, we're going to cat the name file path. So what is this going to do? Oh, the name file path. So I was thinking for a second we were going to cat the name file. So we were going to get like a list of like new line terminated strings, but we're not going to get new line terminated strings. We're just going to get the path of the name file. So we're going to copy whatever the stuff in the wheel, everything in the wheel, I guess we're going to copy to the Bazel directory, which we get by building up dir path and name file path. I think that's my guess about what's going on. PyWheel dist is going to prepare a dist/folder following Python's packaging standard practice. All right. And out is the name of the resulting directory. And then wheel is some wheel stuff. And PyWheel is going to build the Python wheel. Wheels are a Python distribution format defined in this PEP, which I think we saw already. This macro packages a set of targets into a single wheel. It wraps the PyWheel rule. Currently, only pure Python wheels are supported. So I guess you can't do like in Bazel, you can have things like you can have Python call out to C, but I guess if you're packaging stuff up as a wheel, then you can't have like a wheel that has both Python and like C together. I guess you can only package pure Python. Is that what it's saying? And you can package. So here's an example. Package some specific PyLibrary targets without their dependencies. So minimal with PyLibrary. And we've got a tag, a version. And we're going to package these two things, I guess. But the wheel's not going to have their dependencies, I guess. So what does it have? Oh, Yeah, so deps here are the targets, what it's calling the targets, I think. And the dependencies, I guess, would be their like transitive dependencies. All right, so example. Here's an example with all the transitive dependencies. And how do we get that? Only include these packages as examples.wheel. Selecting just the files within a specific Python package. All right, I'm not sure how it gets all the transitive dependencies. Okay, so this is PyWheel, this is PyPackage, and then PyWheel again. Minimal with PyPackage. Package data, we're building an example, blah, 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 distribution, okay. And its dependencies example package, which is this. Okay. To publish the wheel to PyPy, the twine package is required. Rules Python doesn't provide twine itself. Okay, so we can use PyWheel to push a package, and presumably Google does this with their own packages. Otherwise, I don't know why they would have built this. Okay, and so we call PyWheel dist, and I guess get the distribution or this target, I guess stuff we're going to distribute. We call PyWheel on the name, and if we have twine, then we'll do some publishing stuff. We'll call native.pybinary on, I guess, something templated publish format name. The sources are going to be twine main, and args are going to be upload with some root path and some data stuff, and then PyWheel. Okay. And we've got extensions.bazel. Which I'm not sure if I looked at, but I don't think I did. Okay, we've got Python implementation for module and module context modules. We're going to do this double loop. First outer loop is over modules. Inner loop is over attributes from mod.tags.toolchains. We're going to register each of those toolchains. And then Python is going to be set to be equal to the module extension. Implementation is underscore Python impl, which I think we did see. And some stuff like, looks like configuration stuff. All right. Here's pip implementation. We're going to iterate over mod and attributes from tags.parse. All right, we get the lock file. Maybe I did look at this. Create repositories where users load the requirement macro. Under Bazel mod, this does not create the install deps macro. So we have pip repository Bazel mod, which will create the repository. And then we're going to iterate over the name and requirement line and require. So we're going to iterate over the requirements file, grabbing the name and the requirement line. And then we're going to call wheel library for everything. Okay, so this is, I guess, what I was really looking for. So we have the requirements file, and ultimately all that stuff has to be downloaded, right? So this is the line, it looks like, where we actually grab the requirements file, iterate over all of the lines, and for each line we're going to call something. What are we going to call? We're going to call wheel library. We're going to sanitize the name, presumably so that you don't like try to do like SQL injection or something with the name. I don't think there's any SQL here, but I guess there's some reason to suspect that you want to sanitize wheel names or whatever. It's got a reference to the requirement line. And I'm guessing that is just the text. So that would be like the foo library at version 1.5 or whatever, I guess. The repository name, repository prefix, annotations. Set a bunch of stuff like Python interpreter, quiet, timeout, whether to use isolated, some extra pip stuff, and whether it's download only. Okay. And so did we look at wheel library implementation? Let's see if we can we have PyWheel implementation, but I think that's different from wheel library, right? Pi wheel covers depths proto. What are the chances that GitHub will let me search for it? So we import from pip repository, blah, blah, blah. Here we go. I don't think I've seen this private directory. This looks pretty promising. Pip install utils and sources. All right, maybe I'll take a quick look at these and then probably head out. We have a template, a Bazel template, which I'm guessing is eventually people get tired maybe of putting literal string templates in the files, and they have templates that are stored as separate files, I guess. Requirements parser. Yeah, I guess I'll look at all these. Is there anything in tools? Wheel installer. Yeah, I want this stuff. Dependency resolver. Lib. Annotation, argument test, argument, Bazel. Wait, I wanted tools. Okay, wheel and wheel installer. Cool. All right. So we've got compile pip requirements. And so I'm just expecting this stuff to massage names from, wheels might expect names to be in a certain format. Bazel might expect names to be in some other format. And so I'm just expecting this to massage things around the appropriate formats and then just to shell out the wheel. So it may not be so interesting, but I'd like to walk away feeling like I know where like the call to wheel is, for example, so that if anything goes wrong with wheel or whatever, you'd have a sense of where to look. Okay, so where are we now? We are in requirements.bazel. We've got compile pip requirements. It's going to take a bunch of stuff, extra deps, extra args, requirements, Linux, requirements Windows, and generates targets for managing pip dependencies with pip compile. By default, this rules generates a file group named name, which can be included in the data of some other compile pip requirements file that references these requirements. It also generates 2 targets for running pip compile. Okay. Extra args are passed to pip compile. So this is the thing that I assume is going to shell out the pip compile. So pip compile is going to be whatever this label is. Use the label constructor so this is expanded in the context of the file where it appears, that is to say in rules Python. So we're going to get the root path and set it to loc, or rather set loc to the root path. We're going to format a bunch of arguments. Deps. I guess these are deps that Bazel's going to add to all of your stuff, like setup tools, to MLI, import metadata, zip, more iter tools, build, click, colorama, pep 517, and pip and pip tools and setup tools. All right. We're going to, I guess, append some tags, depending on whether it... I don't think this is conditional. I think it's always going to append require network. So you need the network to build. Disallowing remote execution, and no sandbox. No sandbox, presumably because Bazel's already doing sandboxing, and extra sandboxing would just be maybe an annoyance more than anything. No remote exec. I think that like Bazel can, when you call Bazel on your like workstation or laptop, it can execute remotely. But I think this is what it's saying. I think that maybe what this is saying is that like when that remote executor or executor calls pip, don't have like an additional level of remoteness. Just execute on whoever called it, I guess. That's my guess. And then we've got some attributes. We can detect the Bazel version in a cheap way. maybe some environmental variable stuff. And then we're going to call pybinary a name. The name's going to be name.update. So whatever we called pip compile with, I guess, it's going to have, we're going to create a new pybinary that's like an updated version. I guess this is essentially priming, like, you have a function and you have like an f prime version, like a modified version. We'll set the timeouts. And then we're going to call pytest. What? What's this pytest? We're going to call pytest on name test. Maybe, but where do we actually call compile? Did we do that? No, this is just generating the targets for managing pip dependencies. Okay. So this is not calling pip compile yet. It's just generating the targets. By default, this generates a file group named name, which can be included in the data of some other compile pip requirements. Okay, cool. All right, what else we got? We got dependency resolver.py. This set defaults for the pip compile command to run it under Bazel. Dependency resolver. Annotation style stuff. Select golden requirements file. Switch the golden requirements file used to validate if updates are needed to a specified platform specific one. Fall back on a platform independent one. Okay. So we get the system platform and we might return requirements.linux. I guess you might have multiple requirements files and this one's just finding the one for your platform. And then we get this if name equals main stuff and checking system args. And we're going to get requirements in. We're going to essentially parse args and stuff. Get the requirements file. Check some like compiler flags or compiler environmental variables. Set update to true. Detect if we are running under Bazel test. If we are running under Bazel test, we'll set update to false. And pip compile wants the cache files to be writable, but if we point to the real user cache, Bazel sandboxing makes the file read only and we fail. In theory, this makes the test more hermetic as well. Okay, so I don't, let's see. So we're going to append a cache stir and set a test tempter. All right. And then we're going to copy some stuff. So shutil compile. These two files won't necessarily be on the same file system, so we can't use os.replace or shutil.copy file. Okay. So I guess because of sandboxing, we may have to copy some files another time, I think is what it's telling us. I'm going to set the update command to whatever the custom file is or Bazel run whatever, run the target. And custom compile command stuff. Add some arguments like generate hashes and output file and if update, which I think basically means we're not in test. We're going to print updating and then the requirements.txt file, or I guess the content of the file. We're going to check if whether like build workspace directory has been explicitly set, and if so, we'll do some stuff, and we might have to worry about whether it's a symlink. And then we're going to call cli, which I assume is command line interpreter or command line something or other implementation. All right. Or interface. Okay, so if not update, else means if we're not update, then we're going to try checking the requirements file. We're going to call cli again and catch some exceptions. And so like pip compile might fail with code 2. And do some more exception handling. And then, cool. Then what's cli do? It's going to call pip tools scripts compile. So this is presumably some just a bash script that calls pip. I don't know what pip tools is. Is pip tools part of Bazel or is this This might be an external thing. Let's see. Yeah. Okay. This seems so they seem to be calling out to like a library to compile with pip, which is totally makes sense. All right. Here's wheel. And I feel like we have a better sense of what's going on with wheel. Now that we know where pip is called, I think things make a bit more sense. And wheel's got entry points and versions. Entry points returns the entry points defined in the current wheel. So I don't know what entry points are, but I guess this is like where you can call the binary you've distributed. We'll take a quick look. Entry points are a mechanism for an installed distribution to advertise components it provides to be discovered and used by other codes. Okay. So you might point it to like various scripts or whatever, or the binary itself, or you might have multiple binaries maybe in the same package. We've got dependencies. And the dep set, we're going to start by setting the dep set to the empty set. And we're going to iterate over wheel requirements in self metadata.get all requirements dist. And we're going to call package resources requirement on the wheel requirement. And yeah, so I think we're just going to get the requirements from the wheel, I suppose. So what are we doing? Oh yeah, so this is essentially a model of a wheel file. And one of the things it can do is get its requirements. I guess wheels probably include requirements somehow, which would be normal for a package manager. We can unzip, and that's basically it. Cool. Wheel installer. You can configure reproducible wheels. Modifies the environment to make wheel building reproducible. Wheels created from sdists are not reproducible by default. We can, however, work around this by patching in some configuration with environment variables. All right, this looks cool. Wheel by default enables debug symbols in GCC. Really? This incidentally captures the build path in the .so file. We can override this behavior by disabling debug symbols entirely. Okay, so we'll disable debug symbols. That removes the build path, which is if you run, I guess, Bazel on different machines in different directories, they would produce different results because of the build path being included as a literal. We're going to set source date epoch to 1980 so we can use Python wheels. Huh. Okay. Python wheel metadata. I don't know why 1980. The link is some Nix OS thing. Python. Did we check it? I mean, this would presumably prevent anything that includes timestamps from messing with your reproducibility. I don't know if that's the only thing this does. Let's see if you can find 1980. Zip does not support timestamps before 1980. Okay, so I'm guessing it's set it to 1980 instead of like 00000 or whatever. Hey, Python wheel metadata files can be unstable. All right. If Python hash seed is not an OS environment, we're going to set Python hash seed to 0. So I guess the hash takes is randomized somehow, and it takes a seed, and we're going to make sure that the seed is always the same so that we get a reproducible build, I guess. And then we can parse requirement for extra stuff. And we can set up namespace package compatibility, generate entry point contents. Okay. Generate entry point rule name. Generate entry point rule. Generate a Bazel Pi binary rule for an entry point script. Okay, so the entry points are part of the wheel, right? So the wheel, I guess, has some some executables or whatever in it, like Python files you can run. And this seems to be like it's generating, it's grabbing the entry points and then generating Bazel rules for them. Generate copy commands. I don't know what that's about. Generate build file contents. Generate a build file for an unzipped wheel. Okay. So this is the stuff that generates. We want to convert the wheel, which is a Python specific description, to a description that Bazel understands. And this is the file where it seems like all that stuff happens. So it's peeking into the wheel, getting the information it needs, and then generating the Bazel build files. Here's a function extract wheel. It's going to extract the wheel into the given directory and creates a Py library and file group targets. Okay. So this is cool. This is, I felt a little bit what's the word? Disoriented. But now I'm seeing the kind of stuff that I was really expecting to see. And it turns out that it's in pip install/tools. All right. Here's the pip repository.bazel. We can construct a path. We can get the Python interpreter, get Xcode location C flags. I guess Xcode meaning the Apple toolchain thingy. Yeah, toolchain Unix stuff, use isolated. Determine whether or not to pass the pip isolated flag to the pip invocation. Optional attributes. All right, I think I'm just going to just verify that nothing too insane is left out there, and then I'm going to head out. So what do we got here? Sources.bazel, a generated file containing all source files used for rules Python / Python / pip install pip repository.bazel. It's auto-generated. So here's a list of the stuff. Most of this looks pretty familiar. Here's pip install utils. A generated file for the source files, blah, 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 blah. Okay. We've got some template stuff. Here's proto, PyProto library. I think we have a sense of how proto rules. And here's extensions. I think I looked at this. We've got internal deps, module extension, sanitize name. What does sanitize name do? It's going to replace. Oh, I guess that's not a whole lot of sanitize. I'm going to replace dashes with underscores and dots with underscores. I don't know if that's sanitization. That seems like it's just changing the naming convention. All right. We've got pip parse extra attributes. Like the pip repository rule, we end up setting this manually so we don't allow users to override it. Cool. All right, so that's all for the Bazel Python rules. Hope you enjoyed that, and thanks much for watching. See you.